Thanks everyone for coming. I'm Doug Brake. I'm a telecom policy analyst here at ITIF. And I'd like to start off our event as people trickle and get food with a small confession. I think that this event has been billed as a general sort of IP transition, the technology of the IP transition, and we really would like to focus much more narrowly on the issue of numbering today. And so, as Harold put it in a tweet, this is the question is, are you nerd enough? We've got three very qualified engineers here, and I have authorized them to get a little wonky. And so, if this is a much deeper dive into numbering than you wanted, and if you learn more about telephone numbers than you ever wanted, you can blame me and come to see me afterwards for a refund. So that being said, I think that telephone numbers are very important for a number of reasons, for several reasons, and really have not gotten the attention that they deserve, especially as we move forward with the IP transition. So first of all, just with the issue of numbering itself, or telephone numbers themselves, I mean, really for a long time, PSTN numbering was, I think, fair to say, a pretty sleepy area of policy. With main questions, correct me if I'm wrong, but I think the biggest questions were about area codes, where to allocate area codes, if area codes were going to run out, where we need to put new ones. But with the ongoing IP transition, a whole number of questions with regard to numbering come to the forefront. Questions about how we do authentication, the role of telephone numbers in identification and addressing, how numbers get allocated and to who, security of telephone numbers, how do we address issues such as spoofing or robocalling. All of these suddenly change when we look at a world of pure IP voice. Second of all, I think numbers are a key touchstone for sort of the broader policy of the transition. Sort of the larger, more abstract policy questions, I think telephone numbers can provide a good touchstone, and once we have a better understanding of the engineering behind a lot of these issues, I think it can help clarify some of the larger policy questions. Issues about interconnection, how to numbering, and sort of allowing protocols to interact between different networks can be clarified. How we maintain interoperability between different types of networks, and not to mention, of course, the importance of number portability in the realm of competition. So, as I mentioned, we've got three engineers who I've authorized to get fairly wonky. I hope it's all right, Henning, if folks are thoroughly confused, to ask questions while you're speaking. And also, we're hoping to have plenty of time for audience questions at the end, so we're ready for that. Also, we are webcasting the event and hoping to have some live tweets using the hashtag IP transition. So feel free to interact in that way, and we'll also be taking questions off of the hashtag. So anyone out there in internet land, feel free to send questions that way. So with that, a couple of introductions. First of all, Henning Scholzdrein has graciously offered to give a presentation, sort of holding our hand down the rabbit hole from the broad issues of the IP transition down into numbering. Henning is, of course, the Chief Technology Officer of the FCC and a Professor of Mathematics, Computer Science, and Engineering at Columbia University. He's published more than 250 journal and conference papers and more than 70 internet requests for comment. He's widely known for the development of key protocols that enable voice over IP and other multimedia application standards, including Session Initiation Protocol. His research interests include internet multimedia systems, applied network engineering, wireless networks, security, quality of service, and performance evaluation. We also have Tom McGarry. Tom McGarry is an engineering fellow and vice president of research at Newstar. He's been with Newstar since 1998 and has been critical in moving the telecommunications industry to number pooling and driving the development of new solutions for routing telephone numbers on the internet. His research group establishes technology, direction, and strategy both within the company and on an industry-wide basis. We also have Daniel Berninger. Daniel is a DC-based independent communications architect and the founder of the Voice Communication Exchange Committee. Daniel's work started with the original assessment of VoIP at Bell Laboratories in 1995, and offered technical contributions to the founding of Free World Dial-Up in 1996, and continued at Vocal Tech Communications, where he led the first VoIP deployments at Verizon, HP, and NASA. We also have Harold Feld from Public Knowledge. Harold is the Senior Vice President of Public Knowledge. He's responsible for managing and mentoring PK's growing legal team and acting as lead attorney for issues before the Federal Communications Commissions and the courts. He is also the lead attorney for Public Interest Spectrum Coalition. So with that, I'm going to go ahead and turn it over to Henning to lead us down the rabbit hole of telephone numbers. Thank you.
Thank you. Let's see where switch to full screen view.
I vote for another metaphor than rat hole, but
thank you.
What's your vote?
we'll work on it. Yeah.
You're good at those. So thank you for the opportunity to try to, in a hopefully reasonably short amount of time, highlight more issues in kind of the scope as opposed to any of the details, and I hope we'll have an opportunity based on your interests and questions to dive into the technical and policy details of any of those issues in more detail, again primarily focusing on numbers. What I would like to do as a goal is to convey that while we think of a technology transition as something relatively straightforward and something that's been happening more or less organically for a number of years, once you start digging a little deeper, the number of components that are intertwined both historically, because we're talking about 100+ years of communication history that's rolled into many of those systems, economically, and from still a major infrastructure, as well as from a policy perspective, makes the problem much more complicated than it might initially seem. See if I can point to the right place. Now we go. So I'll give you a quick overview, just what some of the facets of a technology transition. It's a topic for an hour-long presentation, which I'll spare you. The role of telephone numbers in general and as part of a transition, because we actually have, as Doug indicated initially, a multifaceted role that is essentially the glue. Just as you find, for example, domain names and IP addresses, even though they're inherently boring, have become an internet governance kind of the nub of the whole internet governance debate. Once you peel back all of the highfalutin language, it's often about identifiers that drive policy discussions. And a bit of a future, because I believe we have both a chance and to some extent a bit of a risk that doing the same that we've done for as long as telephone numbers have been around probably isn't an option. Things will start unraveling unless we do something to prevent that. So when we talk about technology transition, we're really talking not about a singular but a plural. Namely, that we're seeing intertwined pre-transitions that are taking place simultaneously in interacting ways. Namely, we have at the application layer that traditional time division multiplexing voice is going towards a voice of IP environment. That includes VoLTE, voice of LTE, and the cellular stuff. At the transport network, because the TDM network served as a generic platform not just for voice, but also as a generic platform for data services, with T1 data service being a prime example as kind of a basic unit of measurement and interchange, to an all-IP packet world, which just like TDM circuits were special access circuits for non-voice service, they now also serve as a foundation for non-voice service in the IP world. And finally, at the physical layer, where we had a network that was at the access dominated by copper, recognizing that there were other access technologies, but copper was essentially the default mode in a variety of ways, that we have a much more diverse set of infrastructure. were very different properties. So fiber versus coax versus wireless versus copper twisted pair with more or less electronics in the middle, maybe even satellite. And indeed, in most cases, we now not only have a single medium, but almost all cases we see two. Every network has become a hybrid something network. Hybrid fiber coax, FTDN, where you have copper and fiber, radio, anything cellular, which is essentially a hybrid network between fiber and radio, because there is no, relatively speaking, no end-to-end radio network for, unless you're talking about amateur radio. So all of those have become hybrid networks in terms of their physical infrastructure. So when we talk about the universe of IP transition, a different one, I won't belabor that, but I want to point out that we're actually seeing two high-level transitions taking place at somewhat different time scales. Namely, on the left, we have a video transition. And you can see the Aerial and Sky Angel and all the other OVD, over-the-top video distribution, is essentially a separate, somewhat different timed version of the same issue, namely where you had in the past a dedicated transport infrastructure that was single purpose, and now you have a generic transport infrastructure that is now also used by content of a specific kind, namely real-time or on-demand access video. That in itself, just kind of as, I think, as a preview, I would imagine that in a year or two, that topic, particularly as we get more of these distribution modes that aren't quite cable systems, but aren't quite YouTube, completely different beast type of thing from a user experience perspective, that type of transition will also kind of raise its policy head. But now we're focusing on the PSTN and a number of sub-issues such as numbers and 911, primarily numbers here, but I'll talk about more of the sub-issues a little bit later. So the three transitions are all in some way motivated by economics. This isn't so much that there are new capabilities, although I suspect, as Dan will point out, it does offer those new capabilities, but the main motivation really hasn't been about fancy new services. Unlike, say, in the digital transition that we had in the 1980s for the telephone network, where at least part of the motivation was to offer the classical class services like call forwarding and call ID and all of those, which would be 800 numbers, geographic routing, all of these type of services, which were at least to some large extent motivated by offering new services. Here, it's all about money. So the copper fiber transition, for example, is about maintenance cost to some extent. The wired to wireless transition is particularly for deployment costs in rural areas. The circuit to packet transition is a bit transport cost and a switching cost advantage in that. So in issues by those transitions, often we think of the IP transition as a single kind of complex of policy issues, but we're really not. The issues that are raised by a transition at the fiber, from copper to fiber, are very different than those that are raised, for example, by the wired to wireless transition. They implicate consumers in competition, so the basic buckets aren't that dissimilar, but the precise impacts are. And often the discussion isn't helped by lumping all of those together, because then you have one side saying, well, man, what are you complaining about? When you get fiber, you get more reliability, you don't have to worry about storm outages as much, you don't have corrosion and analog noise problems. But the other side really was talking about not the fiber transition, but the people who are left with a 2G or 3G wireless service, and so it's hard to have a coherent discussion because you're really talking about two different facets of that same transition. So when we divide the problem space of tech transition in the PSTN, I like to divide it into two broad sets of issues, again, that have separate implication, namely an intra-network, which are largely single provider, single carrier type of issues, and an inter-network issues where interaction between networks gets implicated. So this is not meant to be exhaustive by any stretch, but just to highlight, for example, universal reach, universal service, whatever you want to call it, geographic, by income, and so on, is largely an intra-network problem, namely, is the incumbent provider, for example, obligated to provide service. Powering issues, what happens when commercial power goes out. Reliability, consumer protection issues, so on, tend to be intra-network issues. But we also have a large amount, and this is where numbering starts to come in, inter-network issues where interconnection between networks has been a classical point of policy contention. 911 issue, where 911 used to be kind of treated as a destination. Now it really often is a network, so-called ESINet. And numbering itself as a facilitator of many of those issues. So this is an illustration of one but misleading fashion of the transition, namely that the classical contribution of the incumbent local exchange carriers to interstate switched access minute means that we're basically back to the volume of calls that we had in 1985. So that illustrates that the network is changing. Not that the network in 1985 was anything fundamentally wrong with it, but it was just a much smaller population among other things. That doesn't mean people have necessarily stopped talking, although that's probably part of it, when text and email and so on has substituted in many ways, but it also means that voice minutes have moved outside the ILEC realm. So one classical problem, and this is appearing now in at least two networks that are not similar in many ways, but share some of the same properties, namely the power grid and the classical phone network, is you have a danger of a death spiral. Namely that you have ever fewer subscribers supporting a relatively fixed cost asset. So these are an estimate, and I should say that not everybody believes those projections, so take those with a large grain of salt, but that you have a set of about 100 million, these are millions, of access lines, residential, and a smaller number of business lines. And you have roughly today, and nobody knows precisely because of the difficulty of actually classifying business and residential, but somewhere in there we've actually had a crossover, that a network that was essentially, let's say, 2/3 residential and 1/3 business turns into largely a business voice network. And that because businesses have been making the transition more slowly, although you do see that as well. If you take a per line monthly maintenance cost model based on some state, you get because the same number of line miles have to be maintained, and if you take that as largely proxy for the ongoing maintenance cost, given that nobody's replacing switches, you get a kind of increase on a per monthly cost gets pretty dramatic. And this is, again, in the power world, we have the microgrid problem in that same sense. We also have the problem that we have is that the infrastructure, despite what people say, when they talk about the rapid technology evolution, we still have a whole lot of old stuff in the network for a variety of reasons that I don't want to go into here. Much of our infrastructure, as in some other realms, is pretty darn old. So the DMS 100, which is reasonably recent addition to telecommunication in terms of seen as a full-fledged digital switch, was developed in 1979, and because the manufacturer of that, Nortel, is no longer with us, is the part supply is often done in two modes, namely cannibalism, namely you kind of switch eats different brethren for parts, or via eBay. There's also a separate problem that not just the switches, but the people who are maintaining those switches also have a same aging problem. And finding people, and this has been a problem in rural call completion, telling somebody that kind of plastic is the future, digital switches is the future, doesn't quite have the same ring. So the number of people who want to get into switch engineering is not really sufficient to just keep up with what's going on. I guess we have to do the same that we did with COBOL programming or something, make it attractive. So what is happening with tech transition? We have a consumer-induced facet and a carrier-induced facet. So again, it is not as if this is just a technology transition because we have lots of things happening all at the same time. We have a landline to cellular transition, but which is very uneven, as Harold has been kind of analyzing a little bit in a different form, by geography, by income, by ethnicity. It's far from uniform. And you could argue that we're reaching some kind of a flattening out phase of that. We don't even know why households keep or abandon landlines. We can speculate, but we have very little real knowledge as to whether that's largely economically driven or by something else. We have the ILEC DSL to a cable transition. By implication, once somebody abandons their DSL line, they often, because of economic incentive, simply subscribe to the voice over IP service of the cable company, taking them out of a traditional kind of world of both regulatory as well as technical. And at the business level, we have a transition between classical PBX-centric services, to the extent that those still exist, and what's called SIP trunking, where you have an IP access. And we have carrier-induced changes, VoLTE, central office upgrades, and fiber conversions as well. I would argue that the first ones tends to dominate in terms of numbers. Many of the traditional carriers actually have, as far as I can tell, with a few exceptions, not done massive conversions of their infrastructure. This is the CDC statistics in terms of the conversion that we're now roughly at the 40% level for landline for wireless-only households. Let me talk about numbers a bit. So, step back a bit. Numbers are really just one example of a communication identifier, largely at least. And we got a number of those, and they all have different properties. Without going through every single row and column of that chart, one of the E164's telephone numbers, for those of you who don't memorize ITU specs, just simply describes how telephone numbers look like. So what you have, generally speaking, is a trade-off between multiple facets. Namely, is the identifier protocol dependent or independent? And so, for example, a Skype identifier is Skype specific. Does it allow more than one multimedia, one media, so just audio or also others? Is it portable in the sense that a consumer can take that same identifier to a new provider? So, for example, a URL that's owned by me, I can take to anybody. I can just get a new email service, for example. But if I have Gmail, I can't take my Gmail ID to Yahoo. Nobody would think of that being even sensible. Telephone numbers are somewhat portable in the sense that you can port it, but not perfectly. Rate centers and other kind of complications get in the way. And you also have service-specific ones, which are not portable at all, like the Skype ones. You also have a notion, can you use it for group identification as not just a single person, but a larger entity? 800 number that doesn't identify a person, identifies a business. Are there trademark issues? Again, big deal for domain names, less so for others. And what are the privacy implications? So, for example, email addresses tend to reveal your name unless you choose some random, non-memorable email ID, but telephone numbers don't so much. And that's a trade-off that people don't often recognize. We also should recognize, and I won't belabor that here, that we unfortunately don't just have a single telephone number that we all think of, a 10-digit number type thing. We have all kinds of telephone number-like identifiers which have become really, really confusing. It's now, you don't even know whether you can text the number or not, because you can't tell whether it's wireline or wireless, but you have these short codes which sometimes work for voice, sometimes for SMS, but usually not for both. You have the service codes, like the 211, 911, 411 type of codes, which generally sometimes work for text, say for text to 911, but only in some places. But for example, 311 generally don't have text to 311. You have toll-free numbers where nobody can keep track anymore as to which prefixes are actually used for 800 number, because you got a bunch of them, and you got these 900 numbers, which presumably nobody uses anymore, unless they went insane. So the telephone numbers are important because they're the universal, and I mean that in the known universe, public communication identifier, which means they ensure reachability. You know when you dial a telephone number relatively, with high probability, as long as that person, as long as it's a valid number, you'll reach somebody. It also is a scarce resource in the sense that in most countries, particularly in the US, that have fixed length telephone numbers, you can't just give out telephone numbers like other identifiers that you might not care about because you run out, and people don't like that when a single region has 10 different area codes. And as was mentioned by Doug, they're very important in enabling competition because they allow new entrants to win customers that don't want to change their public identity. So what are some of the facets of numbers? They serve as an address, fairly obvious, but they also serve as, they're part of a translation function. Namely, an identifier needs to be translated into a physical device address. We know that in the internet between domain names that are location independent, service independent, and an IP address, which is neither. They need to be administered. So somebody needs to sign them, recover those if they're no longer used. That is a big problem for IP addresses, for example, where there are lots of IP addresses which are scarce. IPv4 addresses, extremely scarce, but hard to recover for a variety of technical and legal reasons. And there's a security implication because they're used as a stand-in for your person. In that, and so people assume that when somebody shows up as a number on their call ID, that's really the person that's calling them, which isn't true, unfortunately. I won't, again, belabor this. I'll make the slides available for those of you who want those. We have, essentially, in a modern world, I suspect we'll end up with three broad identifiers as kind of the ones that define communication. Namely telephone numbers, domain names, and IP addresses. And they have very different properties. This comes up when people talk about Internet of Things and so on, where they say, oh, should we use a telephone number, a domain name, or an IP address? That discussion comes up all the time and is often not well informed by the properties that they have. In the networking world, we distinguish broadly between identifier and a locator. Identifier simply is unique within some scope, but doesn't tell you where it is and how you get there. A locator, by name, tells you how to get there, but it may not be unique. Take a street address, for example. Very useful if you take a taxi, not so useful if you want to identify a specific employee. Some of those are country-specific, and the ability to aggregate devices differs between those type of identifiers, and who can obtain those as well. So we have to be careful, particularly as we look into new realms, to make sure that we use the right identifier for the right purpose. So how many numbers do we currently use? Tom should really talk about that. This is a somewhat older projection of number usage. So this is about 800 million or so out there that are being used according to number resource utilization forecasts. In that a very small sliver is paging, and the remainder you can see the white one is ILEC, in case you can't read that. The grayish one, the light gray, is mobile, and then there's some CLEC, which includes voice over IP, presumably, as well. We have a number of area codes. Without going into great detail in those, that we have a fair number still available, but we also have, because of the way a number of area codes are assigned, we do have a fairly low overall utilization because only 345 are on service. It might actually be more by now, it's probably a year old. But we have a number, for example, 0xx and 1xx, which are not currently assignable. Should we use phone numbers for machines? Some people have proposed and actually use telephone numbers as a convenient identifier. For example, every Kindle has a telephone number, even though you don't see it, you don't know it, I probably can't even find it out, because apparently they use SMS to wake up the Kindle when you subscribe to a book, when you want to download a book. What happens is not necessarily a bad thing, but it means that there are now new usages of telephone numbers that impinge on human identifiers. So, for example, should we give every traffic light a telephone number so that you can remote control it? Every meter. There are lots more meters, 64 million or so currently, smart meters. We have obviously 100+ million households, so it could be even more. But there's only about 300,000 or so traffic lights. So let's look at the future of number briefly. These are questions because I don't think anybody has really systematically thought through that, and I really thank the ITIF for starting that discussion in a more public way. Namely, should we treat really telephone numbers more explicitly as names identifiers as opposed to some kind of relatively weird hybrid? Should they be thought of, if conceptually and maybe in some of our policy decisions, as internet domain names? They're probably not sufficiently similar to IP addresses to be useful. I would say the closest analogy in the classical internet realm is indeed domain names, recognizing that they're clearly not similar in some aspects. Should we allow on a policy about multi-homing in the sense that a single number could be assigned to multiple services? Example, you could have a text service with one provider and an audio and video service with another provider. Or like the Google Voice model, where you have a front-end number that then branches out dynamically into multiple back-end services invisible to the caller. So we separate service provision from numbering. A domain name, you can buy a domain name for whatever, $10, $20 a year. You don't have to use it for any service. It's not tied to a service provider. If you terminate your service with whoever holds your number is gone. You can't get it back when you resubscribe to that number. And numbers, unlike domain names, except maybe at the country level, have a geographic association. I've put up a collection, if others know any others, I know I found another one last night. They're magazines that are named by the area code. People associate with their particular region. Is it part of a cultural identity or not? Should their 10-digit dialing be a mandatory one that works everywhere or is even required? Geographic constraints at the sub-area code level, like ladders and rate centers, no, and I won't quiz you here for a precise definition, they're still useful in an environment where you have a zero termination charge type of model, non-geographically based postalized charges, for example, for almost all calls. Are those useful concepts because they have both number utilization and porting consequences? Some numbers are actually valuable, and somebody tried to actually sell a 212 area code, 212 telephone number on eBay for $1 million, probably right next to the listing for the Brooklyn Bridge. But the notion, and I can assure you that that probably does not comport with commission policy, but people do care about numbers, and in other countries we know that 888 numbers are auctioned off. I mean, these are not the telephone numbers, but numbers have lots of 8s in them for whatever reason, are seen as lucky numbers. One particular problem, which I think almost simultaneously the Senate Committee on Aging is having a hearing on robocalls, and indirectly but causatively related is call ID spoofing. Voice of IP has unfortunately been by far more popular with the bad guys than with the good guys. They have very quickly recognized that you can make cheap calls and you can put any number you want into that call. Really good combination if you're trying to annoy a lot of people cheaply, which is basically the business model for illegal telemarketing. Because they can now spoof numbers and they can place those calls from outside the United States at essentially zero cost. We have spoofing services, which are probably less of a concern in that particular, the bad guys don't use those. But we have a fairly developed robocalling infrastructure and economy that largely relies on the ability to spoof numbers. If you can't spoof numbers, it's easy to block the same old caller that you don't want to hear from individually and collectively. if every call is a new number, you can't do that. So you can't read that, but the phone number identity really has three components, namely the number itself, but we also have a textual call ID. So the bad guys often use a spoofed telephone number to make it look like a legitimate entity. Could be a charity, could be a law enforcement agency, could be a government agency, Internal Revenue Service, for example, is calling you, and it will look like Internal Revenue Service calling, even though it's somebody just spoofed the number. People don't recognize that it's just, as soon as you spoof a number, it's just a database dip in some third-party database, and whatever number is there, you get that display in there. And thirdly, the properties that go along with that, people can and do create misleading CNAM entries, even if they don't spoof the number, that kind of look like a real name. So, for example, cardholder services being a famous example. So how do we validate? We need to get to a point as we form numbers that we recognize the ability to cryptographically validate the caller ID. That has to be a requirement, otherwise we will just be swamped by call ID spoofing. For the Senate hearing, I looked at a number. We now get, last month, we got 2,000 complaints by consumers who had their number spoofed. A year ago or so, we only got about 300 or so of those. So this seems to be either there's much more awareness of spoofing in terms of consumer side, or indeed the bad guys have figured out that a good way to evade various policy filters is to do the spoofing. We're looking at, in part of the Internet Engineering Task Force, at an architecture of cryptographically validating call ID. The problem is that it only works, and this is one of these classical coordination problems, if a number of parties that don't necessarily individually have an interest in solving the problem all work together. You need to have an entity that assigns cryptographic keying material that is trusted by all participants. You need to have the carriers that originate the call insert the keying material and sign the call, and you need to have a terminating carrier validate that information. Besides kind of the more operational side, we also need to think about what is the future number administration itself. That has accumulated essentially as we have added new functions, pooling and number portability in particular, we have accumulated layers of management that are probably at least worth looking at in a new model world where the functions probably can be simplified greatly, both in terms of administrative complexity, the ability for bad actors to abuse the system, see the 800 number system, and other cost factors. What we really need are really three things, namely reachability. We need to map a number to a IP address, SIP URL more likely. We need an assignment model, namely that we can track who has been assigned the number. That's necessary for any number of just administrative integrity function. And we want to keep track of who has had the number historically. Again, that's necessary for administrative integrity, utilization, and other factors. But that's really, the database lookup is at some first level of approximation. If we solve that, we solve number portability, number utilization, all of these type of things without having to rely on the classical model where we separate number functions into essentially 3 or 4 components. What we need to define, and we are starting to look at that, we had a first workshop at the Commission a few months ago, as to what are the right interfaces that we need to provide so that one or more entities, and I won't go into details, but that we're looking at is either a hierarchical model, which is somewhat similar to what we have today, or a fully distributed model, which is somewhat more similar to what we do in the white space spectrum administration, where we would not necessarily have to have a single administrative entity. We would have in that model a number of mutually trusting but possibly competing entities providing service to entities that provide numbers. Indeed, you could even imagine that large carriers would self-provision in that, again, with lots of caveats to make sure that that actually works in practice. Let me conclude. What we're seeing is the classical convergence story that's been well documented. In short, namely that all services are just stuff that runs over IP, just with different physical layers. Again, the classical, for some of you who've seen that, the hourglass model. But the transitions are probably taking a lot longer than some people would either like or have predicted. I don't think anybody is assuming anymore that in 2018 we're going to have fully replaced all TDM circuits. And it's not, and I don't think you can blame the FCC for that one. It is
I beg to differ, but we'll get into it.
The PSTN transition is, some of it is natural, some of it is induced by various factors. Natural as in stuff just breaks and ages and gets replaced. We have intra and inter-network issues, and we should be careful to distinguish those because we have different issues in terms of what are responses to those, state versus federal versus other approaches. And numbers are a crucial element of transition because they have a universal communication identifier. And with that, I'm happy to take questions or proceed into the discussion.
I think if anyone else, if there aren't any clarifying questions or anything like that, we might as well kick it to the panel. Tom, I want to start with you. So Newstar sort of sits in the middle, or I guess sort of in the background of many of these issues in the context of administration and local number portability. So you could give us your perspective as that's sort of the administrator's role, and how that role will change going forward with IP transition.
Sure. So what we're talking about here, I've actually been talking about this concept for a few years of the transition, and I call this one telephone number 3.0. 1.0 was when telephone numbers were invented. 2.0 is the mid-90s when we had number portability and other things coming about, which was a big transition. And now we have telephone number 3.0 as we're moving to IP. And, you know, we transitions are hard, and industry-wide transitions are even harder. The one that we're talking about right now, and we've gone through a lot as Newstar, we're the number administrator, we're the number portability administrator. There's really kind of two transitions we're talking about now. There's the transition itself, which is going to be kind of this hybrid of what the phone company looks like now and what it's going to look like in the future, and really what we're going to do for the next 5 or 10 years. It's going to be a long transition, is to figure out what do we want to look like in the second phase, the post-transition world, is really when communications and the internet are integrated. And it will take a while. So when I talk about TN 1.0, 2.0, and 3.0, we really, you know, my experience in this started around TN 2.0, around telephone number portability, and we can probably look back and learn a few things about how transitions worked back then. In about 1997, we implemented the NPAC. And it was a difficult implementation, quite frankly. There were 2 vendors chosen. One of them failed completely. Newstar was the remaining one. We took over the rest of the country, and we had our problems. We had quite a bit of problems. The stability was an issue, and you know, the time frames of doing porting was an issue. But you know, over time, all of that was fixed. We learned things like the law enforcement agencies couldn't figure out who did they submit a subpoena to, because numbers were now moving between carriers. They call the old carrier would say, I don't know, it's not mine. So we integrated a capability into the NPAC that now all law enforcement people rely on before they submit subpoenas. If people remember, in the 1990s, area codes were exhausting dramatically. we implemented something called number pooling, which Henning referenced a few times in the NPAC, which was now allocating numbers in blocks of 1,000 rather than in blocks of 10,000 like we used to. And the NPAC was integral in doing that, because we basically port 1,000 numbers through the NPAC and give it to a service provider, and then port another 1,000 numbers, give it to a service provider. Wireless number portability was again, is somewhat of a disaster. In about 2003, we implemented wireless number portability, and it's worth noting from a consumer perspective, the industry really fought that for probably about 3 or 4 years. What was going on is the entire industry, the wireless industry, was saying, we don't want it. We don't know the consumers want it, so why are you making us do it? And it didn't really break until one of the larger carriers broke ranks and said, yeah, we'll do number portability. And in fact, around the same time, Consumer Reports was kind of hammering away on it. But wireless number portability was in danger for a while. But when we rolled out wireless number portability, people's numbers were being lost. There were services being turned off. It was taking weeks to port. And the issue was that there's two processes in porting a number. There's a pre-port validation process where the two carriers communicate with each other and say, hey, I have this number, we're going to port it. And then you go to the NPAC, you update the NPAC, you update all the routing information in the country, and then your number's ported. The thing that was a problem was the pre-port validation process. And this was new to the industry. They rolled it out. It was a complete disaster, as I said. The industry fixed the problem in an interesting way. They basically took out about 80% of the functionality of this process. They made the process a little more complex, and so they kind of took out all that functionality and made it an extremely simple process. We're going through, I think people are probably maybe familiar, if you're familiar with numbering, if you're familiar with number portability, you know that, I talked about us embarking on this TN 3.0, and we're really in the middle of it and beginning of it. At the same time, we're transitioning Number Portability Administration Center, potentially. If you're not aware, we've been operating it for 16 years. The industry has recommended to the FCC that they transition to another provider, Telcordia, and this is a complex system. So think of this as a transition within a transition. It's a difficult system to run. It's taken us quite a while to fine tune it to the carrier's needs. We've innovated on it with all of these issues with the law enforcement and number pooling to help conserve the numbering plan itself. It's probably worth noting that pre-port validation process I talked about that was very difficult with number portability, with wireless number portability. About 80% of those transactions went through Telcordia, the company that now they want to give the NPAC to, that the industry wants to recommend the NPAC to. What will happen if number portability is a problem? It'll put a chill on porting. It's what happened with wireless number portability. People didn't want to port, they wouldn't port, or they change their number when they port. It's certainly, that's probably a problem for consumers, not necessarily a problem for telecoms, right? If they don't port, that's probably a good thing for them. If they change their number, that's the easiest thing for them. It's actually, the number portability process is difficult. It's a complex process that involves multiple entities, so I wanted to talk about kind of give the context of, we've gone through transitions before. We're going through the biggest one that we're ever going to see, moving to IP. All the things that Henning talked about, security for telephone numbers, allocating them in smaller blocks so that you have numbers for like IP providers as opposed to just telcos. This is going to be the biggest transition we've seen, and it's going to take a while. It's going to take 5 to 10 years, it's going to be rewarding once we're done. And I think we'll have a better system afterwards. So hopefully I didn't take up too much time to answer your question.
So a lot of issues floating around. I think we should go ahead and move down the line, just a couple questions, and then come back to a few issues that have been brought up. So Daniel, you've been an advocate for a lot of the new functionality that will come once we move to an all IP world, especially this concept of HD voice. So if you could talk a little bit about what we need to do with numbering and the IP transition generally to get this advanced functionality.
Okay. So, a couple things. One is I'm going to pick up on Henning's FCC's off the hook on 2018, but the reason I like numbers and I'm starting to think of the IP transition in terms of numbers. Basically, you look at your telephone number and you ask yourself, what kind of capabilities, functionalities does that contain, does that enable? And I think by the time we get to 2018, what we'll understand the IP transition as is when you call up and ask for provisioning of a number, you will be asking, well, is that an IP transition number? Does it have all the IP transition functionality? And one of the principal functionalities that it will have at the other side of the IP transition is HD voice. So if we ask ourselves, why is it that we have the IP transition? The answer is because the PSTN and the FCC is complicit in this process, became an innovation-free zone for a very long time. So back about 1956, they split up with the AT&T consent decree. The telecom industry and the communication industry, or actually telecom and information industry, you run those two industries forward. They had separate networks, separate policies. All of a sudden, Infotech is sort of absorbing all the adjacent applications, and here we are today. Infotech owns everything. There's just nothing left for the PSTN to do, and so we're going to turn the PSTN off. And all that could be done by 2018. I mean, the normal cycle of policy world is about 6 years for the FCC to make up its mind about things. The Manhattan Project took 6 years. So it's not exactly the time that's a problem, it's just the commitment and getting it done. But again, if you think of the PSTN, I mean, the Information Technology Innovation Foundation is not called the Telephone Network Innovation Foundation because telephone networks innovation is like oxymoron. I was at Bell Laboratories for 5 years, and I came to understand why there was no innovation in the telephone network, at least as far as end users are concerned. The telephone call that you make today on your cell phone has the same voice quality as a call had in the 1930s. It's a voice quality that was set by Bell Laboratories, and just ask yourself. The voice quality was set 10 years before the invention of the transistor, long before the invention of the computing industry. How the heck does this happen? And the answer is regulation and the impacts of regulation. And so to finish up, the reason I really like catching the IP transition and thinking of it in terms of numbers is that numbers are the only thing that are going to survive. There is nothing about what we learned and did in the telephone network that will exist on the other side of the IP transition. It's all gone. And so whatever it is we learned about how to run a telephone network, it's all going away. The one thing that's not going away are the telephone numbers. And so, the network compact that the FCC talks about, all those issues should be tied to numbers. And two special notes. Harold and I have been doing this since about '98 on panels and stuff, and so I am fearful 2018 won't get it done. And Henning is had been working on VoIP longer than anyone else in Washington D.C. Back to whatever early '90s, right? So I met Henning around '95. So I'm number 2 in Washington D.C. as far as history of VoIP. And Harold is number 1 for the history of policy in this area. Go ahead, Harold.
Yeah, Harold, I'm curious. I mean, if you could help us sort of pull back a lot of the details, the engineering details to the policy level. You've written a couple of things about numbering. Why is it that this is important? Why does an organization like Public Knowledge care about these sort of technical issues?
Well, first I just have to point out that there are a bunch of things that I disagree with Dan about, particularly about where the delays are, how we'd be doing if we didn't have an FCC. I will point out that We do not have, let me point to the other IP transition, the IPv4 to IPv8, IPv6 transition rather, which I first got involved with in 1998 when the IETF approved the initial standard on IPv6. And that has been running also since 1998. And I don't think anybody here believes that we have completed the IPv4 to IPv6 transition. I don't think anybody here projects that we will complete that necessarily by 2018. And part of that is because these things are complicated. You have embedded technology issues. You have people who do very interesting things with this stuff while it's just laying around and open. But just when everybody thinks that, and the other very important thing about the IPv4 to IPv6 transition is it's entirely voluntary. Doesn't have that produced a bunch of different results than what we are seeing in phone numbers, which is a sort of voluntary but pushed and shoved by policy mechanisms. And some of those differences are good and some of them are bad. It does mean that, for example, when somebody comes up with the idea of carrier grade NAT, they throw a wrench into all of the assumptions about how people would have to convert because we would just not have enough IPv4 numbers because people are very inventive. So I just highlight that there is a tendency in policy circles to look at the FCC as kind of a bad guy in all of this that's holding back all that great innovation. At best, it's sort of a distraction, and at worst, it's deliberately trying to maintain its own authority. And I don't believe that's true. I think particularly when we're dealing with something as large and as complex and as international as the phone system, and the phone numbering system, that we actually need that level of coordination. I got into the phone numbering thing actually when we first started to get into the whole IP transition, and one of the things that bothered me from the public knowledge perspective is we saw there were sort of two elements to the IP transition. There is what are the policy issues that people love to fight about in DC in terms of enabling things like competition and who's going to win and who's going to lose. And then there was making sure that actual phone calls got completed and that things continued to happen and we didn't have, some sort of horrible collapse of the phone numbering system, which, because the phone numbering system and the phone system has worked for so well for so long, people don't actually believe could happen. But I, being a pessimist and looking at all of the things that are kind of drifting around as warnings of potential problems, like will call completion, like the 911 location information, I get very worried that it is entirely possible for us to one day wake up and, kind of like the subprime mortgage collapse, realize that the system that on its surface was looking like it was working real well suddenly collapses because the foundation has rotted out and nobody was paying attention to it because it was very technical. And as we started to get more involved in this, I actually started to push people, have you thought about the phone numbering stuff at all? And most reactions that I got, even from people who are up to their eyebrows in the IP transition, was, no, what's the issues with phone numbers? It just occurred to me that phone numbers are the basis for all of this. Now, admittedly, I got started a long time ago in domain name numbering, DNS and IP, so maybe I just have a thing for numbers. But from our perspective as public knowledge, there are a lot of policy issues that ride on this. We don't have, unfortunately, a lot of technical expertise to offer other than trying to explain to people things like when Henning talks, try to then translate that one further out to be a little less geeky, and then other people translate what we say. It's kind of a game of, dare I say, a telephone. But the problems from our perspective were a lot of times you have competing policy issues. Flexibility versus reliability. Competition versus stability. And there isn't necessarily a right answer. There are a lot of wrong answers. but a lot has to do with what are the expectations that people are going to have coming to the system. And one of the problems is we have depended on the phone numbering system and the phone system to be very reliable. When we talk about why would you think traffic lights need phone numbers? Well, because the phone system was sitting around as a very open system, and we have a lot of traffic control systems that go back to the 1970s and early 80s that rely on very primitive systems that basically can call traffic lights and work in that way, because those were a nice, neat identifier that people could use. And we can convert all of that, but it requires a lot of forethought, a lot of conversion, a lot of hand-holding. And there's going to be huge questions about where does the money come from. So if, for example, we are dependent upon the phone numbering system in some county, Montgomery County or whatever county, for our traffic light control, and that's going to fail because the nature of phone numbers is changing, then Montgomery County needs to suddenly budget to change its traffic control system. And they will want to know that before their traffic control system fails. So fortunately, we pushed very hard for a framework to try to tell you how to judge between these competing policy issues. And I think it was very fortunate that both the current chairman of the FCC and Jessica Rosenworcel and a number of others agreed that, yes, an overarching framework to tell you what are the goals, so that when you are sitting there as an engineering exercise and trying to think, okay, what should I put into this? Tom talked about how the carriers solved a bunch of problems by stripping out a bunch of the capabilities and number portability and making it a lot more simple. So was that a good thing or a bad thing? Well, if your goal is reliability and implementation and competition at a very simple level of services, that was probably a good thing, because it let them actually roll out a system that was stable and worked and reliable and facilitated the kind of competition that Congress envisioned when it passed a law requiring number portability. If you believe that the numbering system can be much more, and that a goal is to encourage innovation, then that's a very bad thing, because you took out a lot of the capacity for innovation that was built into it and made it much simpler for the particular articulated uses. So from our perspective, as public knowledge, public interest organization, first, we'd like to see more public interest organizations actually interested in this issue. And educating themselves both about the technology, because there's an unfortunate tendency in the world to regard this as kind of a black box that will just work no matter what we demand of it, and we don't have to think about it at all. And I think that's a big problem, because then someday it doesn't work and nobody understands why. And because there are a lot of these policy issues that are not engineering issues that are attendant to it. Privacy being a big one. The law enforcement, which is sometimes a counter to privacy but can work with privacy, is how do you balance these things? And as we've discovered over the years, the way in which these things get balanced depends on who's in the room. So if nobody is in the room who cares about privacy, then you put geolocation into every mobile phone without thinking about the fact that you've now attached a tracker to every person in the United States that other people will naturally want to use for their own purposes, whether we approve of that or not. And then you only discover the privacy problem when it comes to people's attention, and there's nothing built into the system that necessarily tells you how to deal with it. So I think it's very important for public interest organizations that care about the issues that are attendant to the IP transition to be paying attention to phone numbering and to be in the room talking about the policy issues that feed these technical issues and design.
Great, thank you. So I want to make sure that we have time for questions from the audience, but Henning, if you wanted anything that you wanted to respond to quickly.
Yeah, I wanted to just make a few points just to pick up on that, because I wanted to emphasize that we often have a tendency, because there's so many things to do, to just say, well, this has been working fine. If we just leave it alone, it will continue to work. And I believe, and I mentioned that in two major networks that underlie, actually three major networks, if you like, that underlie U.S. infrastructure, the water network, the energy network, and the telecommunication network, at least parts of it. Inattention will lead, I'm less worried about a sudden collapse, but we'll have kind of a version of what we see in the water system, where suddenly you just have a lot more lakes in the roads. Because people didn't realize and didn't plan for it, that you have 100-year-old water pipes. what I suspect we'll see, and we're all seeing kind of incidences of that because we have a collective action problem and other issues, that we'll often end up having a poor workarounds where we know a better solution would exist, but because people have to get on with their life, they pick something else. Take as an example communication identifiers that are service specific. Be Facebook, Google, Skype type of identifiers. Really not clear that that serves anybody. We'll pretty soon we'll fold out business cards to contain all of our communication identifiers, and you have to do what you have to do in some other countries where you have to not just ask what is your phone number, but what carrier are you using, because that depends, and people have 2 cell phones. Apparently in Lebanon, and being probably somewhat factional to begin with, they have extended that to the telephone system. That business people have several cell phones because they can't easily reach the other carrier. I don't think anybody wants to get there, but that, as technology transitions, islands are kind of a natural evolution. And so I'm a little concerned, and the number one issues, the reliability issues, the roll call completion, and the robocalling issues in particular illustrate breakpoints that need to be attended to. And need to be attended to collectively, because again, robocalling being an example where the issue I get asked about when I talk a little bit about kind of my day job among non-geeks is, can't you make the stupid stuff stop? You can do all this wonderful stuff about video and the internet and all of that, but I have that technology I rely on. I put my phone, I disconnect my phone, landline phone in particular, because I don't want to be bothered by telemarketers of various shades of legality. There's no excuse for not solving that problem, but it's not a problem that the FCC, for example, can solve by itself, because many of these calls originate outside the United States. But telephone numbers are going to be vital to solving that problem. They're part of cybersecurity, and that's something I haven't mentioned. Everybody talks about cybersecurity. They don't recognize necessarily the 2 very concrete aspects of cybersecurity, namely telephony denial of service attacks on the infrastructure. There's an increasing number of mass calling events, usually for plain old good money extortion. This is payday lenders calling hospitals, schools, public safety answering points to extract money under various pretenses. Basically, we'll shut down your call center if you don't send a Western Union check to our number, address, and also various forms of phishing. The pretexting and other things rely on number spoofing as well. So I believe that the option of not doing anything will have bad consumer consequences, will have bad competition consequences, and it will lead to various very inefficient workarounds where everybody's worse off, and we slowly recognize, just like the potholes appear one by one, that we don't have the infrastructure that we used to anymore.
Great, thank you. So are there any questions from the audience? If not, I have a few left. No questions at all. Surely someone has one. Yes, please.
Could you please speak more about, I guess, the existing call completion problem, and then what the industry and what policymakers should be considering moving forward with the transition as it relates to that problem?
So the spoofing problem, did I hear that correctly? Call completion problem, sorry. All right. So the call completion problem I would argue, has an enforcement issue, and a policy issue, and a technology issue. You know that the Commission has had a number of enforcement actions on providers that have failed in their duty to connect telephone calls. it has a policy angle, which I won't go into in great detail, where the structure of termination and access charges seems to at least encourage bad behavior. It's not an excuse for bad behavior, but it does seem to drive creativity in ways that are not conducive to call completion. Let's put it just very politely. There are clearly actors out there that make a business of not terminating calls, but while pretending to do that. Again, that will hopefully solve itself to some extent as universal service reform kicks in terms of access charges. But there also is a technology issue in the sense that, as I alluded to, because we have many more actors now, and some of the actors have less technical capabilities than they used to. It's gotten a more complicated world, and many more. You don't just talk to AT&T anymore if you're a small rural carrier. You have now wireless carriers to deal with, voice of IP carriers, a plethora of CLECs. I mentioned the SIP trunking one as one example. And what we have found, at least from what we've been told, is that some of the problems are indeed database problems, where because of the way that the databases of where numbers get routed are kept, which seem to often involve spreadsheets and FTP sites and other things that most of us don't use for anything else anymore, is that things get out of sync. And so a number portability doesn't get reflected in what is routed, new number blocks don't get inserted correctly, people don't necessarily understand the way that old systems work. Because the software is no longer maintained, it's hard to get upgrades for even minor new functionality that would greatly help to automate some of these processes. And I think one of the things that Tom probably appreciates, and you alluded to that directly in the number ported one, I'm in the middle of a porting process between two carriers, and I've been struck by how manual and tedious this is today. As in, the new carrier calls you up and says, we're trying to port your number, give us the password for login, or anything else you might have which might convince the other carrier that you actually meant to do that, which is good because we still have cramming. See FCC webpage on recent enforcement action. So old crimes don't disappear, but or modes of criminality don't disappear. I don't recommend that you should hire actors to impersonate consent. That gets to be expensive. The model, however, as I said, in porting is not the way it should be. If you've ever had the experience, it's not as in you can just click on the web page, type in the new carrier, and things just work. It could take 24 hours. You don't know if you're going to lose service in between. So even things that we've taken for granted, Tom and others have worked on, aren't working in a way that is acceptable. The newness of you can port numbers has worn off. People expect that, and we have to live up to that. So real call completion is, again, one facet where we really have a single difficult problem which has at least three underlying causes, namely just greed and criminality or something close to that, technical issues, and just simply that some of the policies are not conducive to the end results that we all like.
So I'm curious about to hear more about this concept of problems with multiple identifiers. If we have different communications protocols. And we end up with multiple identifiers for all sorts of different platforms, different networks. So to what extent can that be solved just by interface protocols, or does this require a centralized database, or is this going to be moving forward? Will we be moving towards one identifier, or you think it's inevitable that we'll have many? I don't know if anyone...
Well, there are a couple of things that aggravate the problems, because on the one hand, it has long been expected, and I can remember when first hearing the discussions around SIP and everything in the late 1990s was exactly that we were going to go to one. Everybody would have one identifier, and it would be translated to these different networks, and there wasn't a technical problem with that. Turns out you have a bunch of different problems. One is a simple embedded technology problem. And we have lots and lots of embedded technology that rides on this stuff. Many of which is hardwired into old systems that cannot be upgraded easily without, every school fire alarm runs over the traditional PSTN and has a number burned into it of how it routes to the fire alarm. And you can solve that problem, but that is one, and I know that people are working on that problem as a way to create an interface that, you could then attach to a school fire alarm system so that it will be translated into an IP signal that will move to the appropriate first responder number. But that's one example of many different problems that will come up. We don't even know how many of these will come up because it's been an open system that people have hooked into. The other is vendor issues. Every vendor wants you to standardize on their product. And that is, of course, the natural thing to do. So when you're talking about competing platforms with competing vendor issues, so everybody who is on one platform wants the standard to favor their particular platform, and they should be the default and everything will translate off of them. And all of their vendors think that's a fantastic idea. And of course, everybody on other platforms with other vendors thinks the same thing. And so you end up with a lot of these issues arising. We have many different fora to try to develop standards. Many of the standards are not compatible with each other. All of which is fine in one sense. You get the marketplace of ideas and competing technologies, but it does mean that the process is going to take a hell of a long time and be very complicated. Finally, I think we have not emphasized enough, phone numbers are an international system. We have obligations, and other people can screw us up because one of the rules about networks is my problems become your problems become my problems. Henning talked about a lot of the incoming bad calls and spoofing come to us from outside the United States where there are more vulnerable systems. And if we want an international telecommunications system, we have to accept incoming calls and figure out how to work with non-cooperative countries or countries where they simply do not have the technical capacity to upgrade their systems and be more cooperative. Similarly, we need to be aware that if our systems get out of whack and it becomes very easy for people to spoof phone numbers in the United States because of the way in which we are managing our IP transition, then we will become a problem country, and other countries will want to pressure us to take steps to get ourselves in line. So it's a hugely, it looks at first glance like a very simple engineering problem, and it quickly becomes a very complicated real-world problem.
The only identifier that really is used for communications is a telephone number, and I've actually been trying to drag that into the 21st century by talking about things like making it a trusted resource, giving consumers control over it so that it's easier for them to move the number from service providers, having there not be a geography aspect linked into it, because if you move, you can keep your number. So I've been talking about a lot of things like that. In fact, but the problem is everything's moving. Things are moving in the other direction. They're moving to where and there are some people that will tell you that when I'm on LinkedIn, I don't want to talk to the people that are on Facebook. I want to talk to friends on Facebook. I want to talk to business colleagues on LinkedIn. I want to talk to other people on whatever. So we're actually going to this place where you do have multiple identifiers, and they don't necessarily interoperate with each other, some of the things that we can do with telephone number 3.0, as we move into the IP network, if we drag telephone numbers into the 21st century, can maybe help improve that and keep telephone numbers, because I think people, I'm a telephone number geek, but I think people like telephone numbers. They're familiar with them. They know how to use them. They know how to use them on little keypads. We'll see where it goes. Most people see the exact opposite happening, is telephone numbers going away. And one other thing, Harold, before you go, that people ask me all the time, what's the what's going to replace telephone numbers? What's the next thing's telephone numbers? And I tell them all nothing. There's going to be nothing else. There's no way that there's a globally managed resource unless someone figures out how to make domain names more friendly than they are. There's going to be nothing that's going to replace telephone numbers. You have telephone numbers, and you got your Facebook ID and your LinkedIn ID, et cetera, et cetera.
Yeah, and I just wanted to add one more point that is often missed is from a consumer perspective. We have not only a lot of embedded technology, we also have a lot of embedded other things. I mean, the fact is that I have a landline, I've kept it, I've actually enjoyed the ability to port it from, now through several different landline carriers. That number is associated with a lot of documents and things that I use, including, some things that are relatively easy to change, like my giant savings card, but other things like the default phone number for my school to reach me or for other people to reach me because I particularly want to deal with them on my home line and not have them be able to reach me anywhere at any time on my cell phone. By contrast, I have now a large number of things that the primary number or the contact number, the identifying number, is my cell phone number rather than my landline number. I think for a lot of consumers, on the one hand, people don't like proliferations of numbers. It drives them crazy trying to remember which number did I use, which did I use with my bank account when I set that up as my primary number, and which did I have as the alternate number, and if I move now, who do I have to call because it's hooked to my landline versus who do I don't have to call because it's hooked to my cell. But at the same time, I don't think you could get all consumers to just switch to one universal locator because nobody would be able to figure out, which forms they have to go back and correct and change, and they would be sure to miss a couple, and then everybody would hate the FCC for making them do that.
So, and just to pick up on Tom's comment is, if you were to say we had no telephone numbers, but you have a set of requirements that you would think would be good from a communication identifier. Namely, you want it to be international, meaning you don't have to read Chinese or Greek or Russian or Latin characters. You want it to be relatively short so that you don't have to worry about typing it out on small keyboards, and email addresses are on average, I did the calculation, about 20 characters long, so about twice as long as telephone numbers are. And you want something which is semi-anonymous, namely it doesn't reveal more than you want it to reveal. You don't have to tie it to your geography now with voice over IP. You don't have to tie it to your name, certainly. Domain names don't tend to have that flavor. We would probably arrive at something which looks remarkably like a telephone number. And so the danger that I see is that because of the limitations of numbers that we have not fixed, and I want to point out, but one we've mentioned is the kind of limited portability, like you can't take your phone or your home phone number with you. What you'd really like, ideally, is a family identifier, a household identifier, which happens to be on your landline, but really is, if it's for anybody in my household, this is what I'll give. Mm-hmm. Long-term permanent, when my son moves out of a home, he'll start his own, so to say, that he passes on, we'll keep out. The second piece is the control piece. What has not happened is, and this has been a problem, that we can't really control as a consumer what happens to phone calls. To some extent on cell phones, but on landlines, it's not really, I can't choose who calls me. I can't choose what information is displayed to people from a directory perspective or a validation perspective. I can't choose as to which services are attached to that. And that then partially leads to the LinkedIn versus Facebook problem, which to some extent I would say is really one where the ability that we built into the SIP type of infrastructure to do call routing based on user-described functionality, programmable phone services, user-programmable phone services has not taken off. And that to me is really where innovation could take place, where The Commission is not directly involved to the extent that it doesn't affect consumer protection or privacy issues, but we haven't seen as much industry efforts there, and that's been a problem, for example, in the inability to deal with robocalls. Partially is if you look at a particular solution called Normal Robo that's been trying to deal with robocalls on a kind of kludge-on, in a good way, add-on way. They had to do that because there is no universal API that allows a third party to offer call-related services so that you can choose which calls to receive, whether you want to receive a telemarketing call, whether you want to receive the politician asking for your vote, or whether you want to receive calls from people that only from people you know, or from people that you believe your elderly parents should be called by, as opposed to the charities and potential not criminal, but maybe undesirable callers.
Let me just say what Henning said with sort of the innovation answer. We get into a lot of trouble, especially with policymakers that can make rules, looking backwards about how we did things in the past. And I think numbers and addressing is an example of that. Basically, in the future, we will all have 45 different devices. We will have no clue as to what the address for that device is. I don't even know my wife's phone number anymore. Basically, she happens to be in my address book or whatever, great. All that information will be sucked into the cloud. So when I provision a device to my cloud provider, whatever provider that is, that provider will know where that device is. And when I'm contacting people or connecting, sending email, whatever, I will send it to a provider and a person. That will be the addressing, and we don't really. And there's a lot of potential functionality. We don't know what's important and what's not important, but the backward-looking. This is a telephone number. Associating telephone numbers with every device. It can't work because again we already have too many devices for that. And so going forward, I don't really know how it's going to play out, but there will be kind of a different world going forward.
Any other questions from the audience? All right, great. With that, thank you very much, all of our panelists. Thank you all for coming.